Hey guys, HackerSploit here, back again with another video. In this video, we're going to be taking a look at how to use ffuf or ffuf. I'm not really sure how to pronounce it, but again, there you are. And the way I'm going to be approaching this is by utilizing a try hack me room that's been set up to explain how this tool works and how it can be used for enumeration, fuzzing, and directory brute forcing. It really is a great room. I recommend checking it out. And also, again, this is a tool that's sort of the new kid on the block when it comes down to, fuzzing and directory brute forcing. Really, I've also, been implementing it into my own pen tests and stuff like that, just to get a feel for it. And really is a fantastic tool. It really is an all-in-one tool that I really haven't, been able to find so far when it comes down to fuzzing, directory brute forcing, etc. You typically utilize various tools to do each of these tasks, really. But in the case of ffuf, I'm just going to be calling that. It really integrates all of these key pieces of functionality in one, and I think it does it really, really well. That being said, let's actually get started. Right, so in order to get started, you're going to need to install the tool. And by the way, if you're not familiar what ffuf stands for, it stands for Fuzz Faster You Fool. So, we have these creative names once again. And as it says here, it's a tool used for web enumeration, fuzzing, and directory brute forcing. It already is included in the repositories for these pen testing distributions. So Blackarch, Pen2, Kali, Parrot, and you can also search Repology for other distributions. Right, you also require sec lists to actually follow along with this particular room. I just want to make sure that that is clear as possible. And in any case, if you are a pen tester, you are using sec lists to a certain degree because it really is an awesome collection of word lists. The link to that is provided here, I believe. We can actually check that out. Yeah, these are the instructions, the installation instructions for the word lists. You can actually check them out. Fantastic. I highly recommend using this particular collection of word lists, as it were. Really, really helpful for every aspect of pen testing, whether you're doing web app pen testing, pen testing generally speaking, etc. So you can install ffuf on Kali by typing in, sudo apt-get install ffuf, right? And let me just paste in my password. I already have it installed, as you can probably tell. There we are. So we have that installed. So let's actually confirm that. Yes, we have it installed. I also have seclist installed. You can also install seclists on Kali by using the aptitude package manager, and that should be done. All right, cool. So let's move on to the basics, right? So the help page can be displayed using ffuf-h, and it'll be useful as we will be using a lot of options. So let's actually do that. Let's get a feel for the tool we're going to be utilizing. As you can see, it's quite a comprehensive help menu here, and it's sorted out really, really well. So it's sorted into categories. So when you're dealing with HTTP options, these are the various options you can utilize, and we'll get to them when we get there. We then have general options, things like verbose or colorizing output, which I use quite often. And we also have the matcher options, which is a filter, or when you'll be filtering through your actual content. And you also have your filter options. So match options essentially match out results to the to the results that you actually want displayed. So in this case, you can actually match regular expressions, HTTP status codes, the HTTP response size, which is also very helpful. And then your filter options allow you to filter HTTP status codes from response, right? You can also filter regular expressions, etc. And then you have your input options and your output options. So you can actually output your file, or you can output your results to a particular file. So it also gives you example usage here. And yeah, so let's actually take a look at the instructions here that we're provided with. So we need to deploy the machine. I've already done that. We have the IP here. So it's going to say at a minimum, we're required to supply two options, the URL option and the W option, which allows you to specify a word list. That's quite important. And then the default keyword for fuzzing. is fuzz, right? And it's used to tell ffuf where the word list entries will be injected. So if you're performing directory brute forcing, you typically provide the keyword here under the directory that you want to fuzz, right? If it's at the root of the web server, then you just provide it here, and then the word list you can provide as it does there. So again, using this is fairly simple. Let me just make sure I've copied the URL. So if I say ffuf and then I say URL there, paste in the IP, I'm just going to say this is HTTP because, well, we actually confirmed that it is running a web server. It most likely is. Let's see whether that is the case. Yeah, we can see it's running the damn vulnerable web application. So we can fuzz the root of the web server here. So we'll just say fuzz for either directories or files. So we can say word list and then user share sec lists. And then of course we can say discovery web content. And now it says it's actually utilizing the raft word list, I believe. Well, actually in this case, it's utilizing the big.txt word list. So we can actually use that. So we can say big.txt, we hit enter, it's going to begin performing directory and file brute forcing here. This tool is written in Go, so it's very similar to GoBuster, although I know I'm going to get a lot of flack for saying that, but it works very similarly in that you can specify the amount of threads you want to use. And of course, it provides you with relevant information as to the parameters that you specified. So for example, the method it's using is get, the URL, the word list, follow redirects is set to false, which means it's disabled. Calibration is set to false. The timeout, the default timeout is set to 10 seconds. The default threads have been set to 40, and the matcher is going to display the following response codes. So, 200, 204, 301, 302, so on and so forth, but no 500 status codes here, or response codes, as it were. So in this case, you can see it begins the process here, and it's going to take a while depending on the amount of threads you're using and the size of the word list that you're using. And we're already able to start discovering directories here. So for example, the config directory, if we try and access that, it looks like it's redirecting, but that pretty much tells us, or that tells me rather, that this is a directory. There we are. We can see that that is the case. We have the config.inc file here, so on and so forth, right? So immediately we get the hidden directories and files, so on and so forth. So let me just terminate that there, and let's take a look at the instructions it provides us with here, right? So that's the first option here. It also tells you that you can use any custom keyword instead of fuzz. You just need to define it like this. So we, instead of saying or providing fuzz here, we can specify our own custom keyword. In this case, the keyword specified here is noraj, and then the word list is specified there, and then we can specify that we are using our custom keyword by using a colon and then specifying the keyword to actually match. All right, so that would look something like this. So let me just clear out my output here. If I wanted to say the keyword here that we're going to be looking to inject our words within the word list. So for example, I can say, we can say here, right? And then of course at the end here, we just use a colon and then we say here, we hit enter, and we'll pretty much get the same results that we did when we used the default keyword, which was fuzz. All right, cool. So I'm just going to let this run. The reason I'm doing that is because it looks like we need to provide, it's going to say, what's the first file you found with the 200 status code? So if we take a look at the results here, we don't have any 200 status codes yet. So again, you can either do it this way, or you can do it using the default keyword. I'm just going to do it using the default keyword, just so that we have a standardized setup here. And if you're following along, you can actually do this. So again, I'm just going to wait for this to actually provide me with my first result that does have the status code of 200. So just going to let that complete. All right, so it looks like we got our first result with the status code 200, and that is favicon.ico. So it's actually the favicon itself, right, for the website. So we say favicon.ico or icon, we hit enter, there we are, answer is correct, and we can move on to the next stage, or the next task here, as it says. And this is going to involve, let's see, this is finding pages and directories. So this is directory brute forcing, right? So in this case, if we're looking for, it's essentially giving you an introduction to, finding hidden files and directories. And it says here, you need to actually utilize the correct word list in either case. So for example, if For example, we're trying to find, a generic list of files or, a list of hidden files on the target web server, then we can use the raft medium files lowercase.txt word list, right? And what we'll do is we'll just actually do that right now. So I'll just terminate that, and we'll head over here and web content, and we're then using raft, and I just want to make sure that that is correct. That is raft medium files lowercase. Medium files lowercase, right? .txt. We hit enter, and you can now see it's only going to give us files, right? Because the word list only contains files with their relevant extensions, right? So in this case, we have a few 200 status codes here. For example, login.php. Let's see, robots.txt. We're also able to find so on and so forth. Let's take a look at what this is actually telling us here. So it's going to say, however, using a large generic word list containing irrelevant file extensions is not very efficient. That's very true. And it says instead we can actually assume that the index.extension is the default page on most websites. So it's essentially saying every website has an index page, whether it's index.php, index.html, index.asp, etc. And we can try common extensions for just the index page to determine what programming language or the languages the site uses. So what this is saying here is this is primarily to do with enumeration, and more specifically a web server enumeration, in that you're trying to identify what stack is being used here. So, is it running PHP? Is it running the LAMP stack? Is it running Microsoft Web Server, etc.? So in order to do this, we can use the web extensions.txt word list. So let me just head over into my terminal here. And, if I just list out the contents of the file here, so user share, sec lists, discovery, web content, and then we're looking for the word list. Let me just make sure that is correct. Web extensions, web extensions.txt. You can actually, sorry, I actually wanted to cat that, my bad. Let me just head over there. There we are. Cat that out. You can see that this file contains a list of extensions that again can be used to identify what stack is being used on the web server. So you have ASP for Microsoft Web Servers. The same goes for ASPX. We also have CGI, DLL, EXE, HTML, HTML, so on and so forth. You get the idea. We also have PHP, right? So we can use this to identify what stack is running. The way we can do this is simply by fuzzing the index page, and then of course providing the fuzz parameter. And of course, we're not providing a dot here before we provide the actual keyword. The reason we're doing that is because this word list already contains the dots as a prefix to the actual extension. So what this means is we can say, if I just head over into the first command here, we'll say web extensions for the word list, web extensions.txt. And if we head over here, we can say index fuzz, right? So index fuzz, we hit enter. And in this case, it pretty much tells us, with quite a lot of certainty that this is a LAMP stack, because we have PHP running here and PHPS, that's the other extension, but we're running PHP. So that is fairly simple. We're already able to identify that given the fact that it's running damn vulnerable web application, and we were able to tell that it is PHP here. The login page it redirected us to was a PHP file. So that's fairly simple, but can be very useful, right? As it says right over here, it provides us with the instructions there. So it's going to say, now that we know the extension supported, we can try a list of generic words without an extension and supply the extension we know works. So what this means is we can exclude PHP from the results and see what other files that we can find with other extensions. So as it says here, we'll exclude 4-letter extensions from this word list as it will result in many false positives. So we can fuzz the root of the web server and then use the raft medium words lowercase word list and then exclude PHP and TXT files. Because we already know that it's already running PHP, and we're excluding these results to find other files here. So that can be done again if we just head back over here, and we are using raft medium files. I believe that's the case. Raft medium words instead of files. So raft medium words. Lowercase .txt. We're then going to exclude .php and then .txt. Right? We hit enter. And that's going to exclude, let's see whether that actually is the correct syntax there. There we are. We'll exclude the 4 letter extensions. In this case, it looks like it's still displaying that here. Let's see. Directory names are always not dependent on the type of environment you're enumerating. It's often a good starting point before attempting to fuzz for files. If we wanted to fuzz directories, we only need to provide a word list. Did I provide that correctly? It looks like I did. Let's see whether that was actually provided correctly, the arguments here. So php.txt, yep, that is the case here. And in this case, it's still showing us status codes here that are, again, not really useful. However, we'll get to status codes in a few seconds. Right, so it's going to say, as it says here, we need to provide or perform some directory brute forcing. So let's actually do that now. So I'm just going to terminate this here. So raft medium directories lowercase, right? We'll get rid of the exclude option there. Raft medium directories, and then that is lowercase .txt. We're going to fuzz that now to find directories. So there we are. We have docs config. So this will provide us with the actual directories, which again have the status code of 301, which is a redirect. Which pretty much means that they work regardless of whether we may have the permission to view them or not, as is the case if directory indexing has been enabled or disabled, right? So as for the text file that we did find, let's take a look at the results here. We were able to find, let's see, robots.txt was one of them, I believe. Yeah, there we are. So if we type in robots.txt, let's hit submit here. There we are, that is correct. What 2 file extensions were found for the index page? That was PHP and PHPS, right? Hit submit, that is correct. What page has a size of 4840? So let's take a look at the results here. We identified here it's about.php. So we type that in, about.php. We hit submit. And then it's going to ask us, as it says here, how many directories are there? So if we take a look at the directory brute force, we can see there are 4 or 5, I believe. We have a blank directory here for some reason, but let's try 5. Let's see whether that will work. No, do we have 4 directories? Yep, that is correct. My bad. So we have 4 directories there, and we're pretty much done with task 3. So now we are going to be using filters, right? So this is where things start getting interesting, right? The reason why filters are so important when it comes down to directory brute forcing or fuzzing is because it's going to output a lot of results that might not be applicable to you or might not be useful. So, for example, a 403 HTTP status code indicates that we're forbidden to access the requested resource. Let's hide responses with 403 status codes for now. We can accomplish this by using filters. So FC stands for filter code. That'll essentially filter out the actual code there, which we can change to 200, 403, any HTTP status code that we want to filter. We can actually use that here, right? So let's actually do that now. So if we say raft medium, let's use the word list that it's actually recommending here, files lowercase. Instead of directories, we're using files now. Yeah, that is correct. And then we say the filter code here is FC403. So we're filtering any responses with the HTTP response code 403. We hit enter. All right, as you can see, it tells you here the filter is 403, and now it only displays results that again do not include any response with the response code 403, right? So, you know, we have 200, 302, which are expected, as I said. And yeah, that looks to have cleaned up the results much, much better. But as I said, we don't want to actually filter 403 because, again, in many cases, you typically want to limit, results that really aren't useful at all. So as you can see, it says here, sometimes you might want to filter out multiple status codes, such as 500s, 302, 301, etc. So, if we only want to display status codes or HTTP response codes for maybe 200, for example, which is, actual successful response code, then we can match the code to 200 and then, essentially get rid of any other response codes or any of the results with the response codes that don't match 200. That can be done by saying, instead of FC, we can say match code 200 We hit enter. As you can see, response status is only going to display files that match the response status with the HTTP response code of 200. There we are. As you can see, we now have a much cleaner and much more accurate list of results to work with in regards to what we can access already. And these are of course going to be limited to files. You can do the same for directories. However, as you know, directories will typically have a redirect, and in many cases, if we don't have permission to a directory, we'll get a 400 response code, which doesn't mean that that doesn't exist. It means that we don't have permission to access it. So you want to be very careful with your filter and match codes. All right, cool. So as it says here, sometimes it might be beneficial to see what requests the server doesn't handle by matching HTTP 500 internal server error response codes. So, you know, that can be used to, again, find, as it says here, irregularities in the behavior of the web application. That could help you understand how the web application works. We will not actually take a look at that because you simply need to change or use the actual match code 500 option here. It then goes on to say there are many other filters and matches. For example, you could encounter entries with a 200 status code with a response size of 0. So, for example, functions.php or inc under the inc directory, so myfile.php. So we can, again, perform fuzzing under a different directory and then filter the response codes as it actually does here. So the way this would work, and of course, this is relative to Apache and PHP. So let me actually just change that to filter code 403, and then we're still using files, so performing file brute forcing here. We can say this is under config, and then we fuzz that, but under that particular directory. So we can hit enter, and let's see what we're supposed to do now. So we're just going to wait for this to complete enumerating. You can see we're able to detect the config.inc.php file, which we were able to discover by manual enumeration as we did within the web browser. But, you know, we can also do it this way. It's going to say here, unless we have local file inclusion, this kind of files aren't interesting, which is true. So we can use the filter size of 0, right? So if we take a look at the filter options, we can also filter HTTP response sizes again, in order to limit the results to files that contain data, as opposed to files that are empty or don't have any content that you know, is or are beneficial to us. So as it says here, we often see that there are false positives with files beginning with a dot, so htgroups.php, etc. They threw a 403 forbidden error. However, those files don't actually exist. It's tempting to use the filter code 403, but this could hide valuable files that we don't have access to. So instead, we can use a regular expression to match all files beginning with a dot. So again, that can be quite useful. So again, we can use the filter, as it says right over here, the filter regular expressions option, and then specify the regular expressions. In this case, the regular expression filter is limiting the results to files that begin with a dot. So we can actually replicate this. So raft medium files lowercase. Let's do that. There we are. And then filter regex, and we hit enter there. Let me just head over here and let me get rid of the config folder. There we go. And in this case, you can see that it'll actually, as we already did here, filter the output. Let's actually take a look at the results here. There we are. Filter the filter regex, or use the regex filter here. And in this case, we're, again, as it says right over here, we can use the regular expressions to match all files beginning with a dot. And of course, we can also utilize the response codes to, again, only limit it to response codes like 200 or any other response codes that you want. All right, so let's take a look at the actual question. So it's going to say, after applying the FC filter, or the filter code filter, how many results were returned? So let's actually take a look at that right now. Under the FC option, how many results? Probably just one, I guess. Let's see if that's correct. That's incorrect. So I guess that is for the directories, right? Instead of files. Let's take a look at that here. FC files. There we are. Let's take a look at what is displaying here. how many results were returned. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, so about 11, I guess. Let's hit submit. There we are, that's correct. After applying the MC filter, how many results were returned? So match code, in this case, it looks like 1, 2, 3, 4, 5, 6. Let's see if that is correct. That is correct, there we are. So which valuable file would have been hidden if we used filter code 403 instead of the filter rejects option here? So if we take a look at filter code 403, we were able to find config.inc.php, but when we used the rejects filter here, we were able to identify WordPress forum.phps. I think that's the file there. Let's copy the file name there and let's paste it in there. Let's hit submit. That is correct. All right, excellent. So that is the fourth task, which deals with using filters. So now let's take a look at fuzzing parameters. And in this case, it looks like we need to deploy the new machine. So I'm just going to terminate the old one and I'm going to start the new machine and wait for that to assign an IP. And then we can begin with the next task. All right, so the new machine has been started and it's actually highlighted this, but it says for this task, we'll be looking at parameter fuzzing, right? So this is where things get really interesting. And this is why I really like ffuf as a tool, because it's really been quite intuitive when it comes down to parameter fuzzing, right? So it says that this is the base URL we will be fuzzing. So if I just copy that there and let's open that up here, let me just paste that there. And we want to access SQLi labs. It looks like this is a vulnerable, there we are, SQLi labs. And well, that's actually not, we're looking for lesson 1, I believe. Lesson 1, there we go. So there we are. So this looks like a vulnerable web application that is there to teach you SQL injection. So as it says, please input the ID as parameter with the numeric value. So what this means is if we say ID equal 1, that should dump the username and password for the user. In this case, the username is dumb and the password is dumb. Okay, I'm not that dumb, but let's try another ID here. Let's try ID 10. Ooh, we get the login name is admin2 and password is admin2. So this is a very simple web application that's there to, again, teach you SQL injection. In this case, it's error-based injection. So we're going to be using ffuf to perform endpoint fuzzing, right? Or parameter fuzzing rather. So it says, what would you do when you find a page or an API endpoint, but don't know what parameters are accepted? Well, of course, you fuzz. Now you can do it manually like I did, which again, as it says, I'm kind of dumb in that regard, but this is where we can actually see the power of ffuf or foof, if that's what you want to call it. So discovering a vulnerable parameter could lead to file inclusion, path disclosure, cross-site scripting, SQL injection, or even command injection. In this case, we know we're working with SQL injection. So now that we have that in mind, it essentially provides us with how we can go about performing parameter fuzzing. So we can fuzz the actual name of the parameter in order to discover it. In our case, we already know its ID, but we can do that anyway. So again, we provide the fuzz keyword there in the place of the actual parameter that we want to identify, because on different websites and servers using different web applications, the parameter name is going to be different. It might not be ID, it could be something else. And then we use the burp parameter names. And then we're also using a filter here, which again, I'll take you through in a second. So let's actually do this. What I'm going to do is let me just copy the actual URL here. And there we are. I'll just copy it to that point here. We'll not copy the parameter and the actual ID. And then we'll just say, we'll open up our terminal here, ffuf. And we're specifying the URL. We want to encapsulate this in single quotes. And then we're then going to say lesson 1. We want to fuzz that parameter. And then we then provide the actual ID here, which in this case, the test, will just be 1. And then we can provide a word list, or in this case, it actually colorizes the output. So we use the C option. And then the word list is going to be user share sec lists and web content, well, not web content, but discovery, web content, and then burp parameter names. And then let me just take you through the actual filter that we're using here. So if I say ffuf here, and I open up the help menu, if we take a look at the filter options, if I can actually display that here, there we are, filter options. So FW, this will filter the filter by amount of words in response. So in this case, it's saying let's use 39. So we can use the default option there. This will depend on the web application that you're testing. So FW39. And I believe there's a space there, if I'm correct. Yeah, there we are, and we hit enter. So let's see what parameter we're able to discover, the actual parameter name. In this case, you can see quite easily we were able to discover that the parameter name is ID. Fairly simple, right? This could also have been done manually, but if you're not able to actually identify the actual parameter name, you can use ffuf. And it's almost done going through the word list because that particular word list is quite small. There we are. So we know it's ID now. That's great. We can also, you can also use the other word list here. However, as it says here, now that we've found a parameter accepting integer values, we'll start fuzzing the values. At this point, we could generate a word list and save a file containing integers. As you noted, we were testing it manually. So for example, if I hit 100 here, the integer 100 or the ID 100, that doesn't respond with the user. But when it comes down to web app pen testing, it's good to know or to get a list or a, to get an understanding of what IDs actually work, or what is the range of IDs that actually work and what integers don't work. So if I say 20, that doesn't display anything here. If I say 11, we get admin 3, and I can go and do this manually and hopefully go through it step by step to find the actual range, but that'll take time. So this is what ffuf will actually help you with. So the way it does this, it uses standard output here. So you can say to cut out a step, we can use the word list option and then a hyphen there, which tells ffuf to read a word list from standard output. This will allow us to generate a list of integers with a command of our choice, and then pipe the output out to ffuf. And then of course we're piping it, as you can see here. And then it gives you a list of 5 different ways to generate numbers from 0 to 255, either using Bash or Ruby. So we can use the first option here. And what we can do is let's actually just copy the entire thing here. I think that should be fine. And then we just replace the IP with the machine IP. So I'm just going to do this in a text editor, and it's fairly simple. You can also do it with Python and then pipe the output there. So you can set up a range of 0 to 255 or whatever integer range that you have in mind. The machine IP in this case is 10, 10, 78, 125. 78, 125, there we are. And again, it's fairly similar to what we were doing before, except in this case, when I paste that in there, we're essentially just fuzzing the actual, as you can see right over here, we are essentially fuzzing the actual integer value or the ID itself, because we've discovered the parameter name. So we hit enter, and now it'll give us a list of integers with their status codes there. As you can see in this case, they're all 200 response status codes. And the reason why it's colorized in this case is because we're using the C option. That essentially means colorize the output based on whether the results are positive or whether, they're essentially redirects or, not found, etc. In this case, we can see, we have a fairly, I think the highest number here is 14. So that's the highest number of, that's the highest range in terms of the integer value there, or the ID, because this is from a database. So that means there are only about 14 users, give or take a few, because I can't see a few integers here. Like 5. Well, we actually can't 5, so we know it's 1 to 14, right? So if we head back over into our browser here, we can see that it's going to ask us the question, what is the parameter we found? Let me answer those questions first. That's ID. What's the highest valid ID? That's 14, I believe. And there we are. All right, so now we're talking about word list based brute force attacks. So for example, performing a brute force against a login page. In this case, under lesson 11, so if we head over there, so we get rid of that there, we say lesson 11, we're prompted with a login page, right? And we can actually take a look at the example it provides us here. So it says we can perform a word list based brute force attack for the password, right? So we're fuzzing the password value, or the actual password here. And the word list we're using is under leaked databases and hack5.txt. And we use the X option if we're sending a post request. As you can see here, we have to use the post method and then provide the post data with D and include the fuzz keyword in the place of the password. We can also do that for the username because it's already given us a username called dummy, right? Which is, sort of holding your hand. But I can actually take you through how you can enumerate usernames and furthermore the passwords for this particular web application. So as it says here, we also need to provide a custom header. So you can find the custom header by analyzing the web app with Burp Suite. So, if I enable my Burp proxy in my browser and open up Burp Suite here, we can actually get our headers. And I'm just taking you through this because the documentation doesn't highlight that. If you're new to web app pen testing, let me take a look at my proxy. That's activated. So if I hit test and test for the username and password and then submit, you get your headers here as well, right? So there we are, application X form URL encoded, right? So you get your headers that way. I'm just going to disable intercept there. And let me just disable the Burp proxy, although we will be revisiting it in a second. So going back to the example, let me just refresh that. Going back to the example, we can actually copy this out as it is quite cumbersome to actually type out. And then I'll show you how we can actually fuzz for usernames and the passwords, right? So we'll just clear that out and I'll paste that in there. And let me try and explain what's going on. So firstly, we're providing the URL, right? We don't have, we're not fuzzing any parameters. We have a login page, but we're using the post method. So colored output word list is a password word list. So again, post, and then we provide the data here, which again, in this case is username is set to dummy and the password is what we're fuzzing. That's the keyword fuzz there, and then submit. And then the content type for the header is provided there. And yeah, that's fairly simple. So let's try and fuzz the username before we get the password, right? So for the password, we can leave that as fuzz, although, we are going to be using a word list for usernames as opposed to passwords, but we can also change the uname value to fuzz, so we can fuzz both of them, although we're only looking for usernames. So if we head over into our word list or setlist directory under usernames, let's see, we can actually use, let's use the MySQL usernames there. That might give us something, although, I'm not doing this in the hopes that we might find a username. So if I hit enter, we get a username. So we get the admin username. So that means there is an admin user, and then we can brute force the password using various password word lists. So for example, if we now change the username value, let me just change this really quickly here to admin. So username is equal to admin, and then we say password equal fuzz, and then the word list we'll be using is going to be under passwords in the setlists directory. So we can then say passwords, passwords, there we are. And we then can use any of these. So, 2020, 200 most used passwords, for example. We hit enter, nothing found there. So nothing under the admin user. We can also use the ROCU word list, nothing there. So I'm just going to try one more before we actually just use the dummy username as it provided, the one it actually provided us with here, so that we can go through this test correctly. Let's try one that I know works really, really well. Do we have the ROCU word list here? The ROCU passwords? I believe we might, but let's try one more here. So common credentials, 100K most used passwords. Hey, why not, man? Let's go ahead and do that. Although, we probably won't find anything useful here, unless we run a few, utilize some of the other password word lists. But yeah, that's how you can fuzz. It looks like we get a very weird output there, but hey, anyway, as I was saying, let's use the dummy username. Let me make sure I get that correctly. The username is dummy with a capital D. That's very important there. So username is dummy. There we go. And then we're using the leaked passwords under, let's see, leaked databases, and then hack5.txt. We hit enter, and let's see whether we can find a password for the user dummy with ffuf. All right, so I'm going to let that run, and it looks like we get the password. So let's copy that there. We can also try and log in, I guess. Let's actually test that out. So if we head over into the web application, we say dummy, log in there. Looks like that works, successfully logged in. So we can provide that here. It's going to say, what's dummy's password? Paste that in there. And there we are. Fantastic, done. All right, so we can close that task, and let's move on to task 6, which is finding vhosts and subdomains. Let me just terminate that. I've actually terminated it. So now we're talking about subdomain brute forcing and also vhost brute forcing. So it already tells you this from the start, that ffuf may not be as efficient as specialized tools when it comes down to subdomain enumeration, but it's possible to do so. All you need to do is provide the fuzz keyword and then the .domain.com or domain.org or whatever top level domain you're trying to enumerate subdomains for. And then you use an appropriate word list, like, under the discovery and DNS directory, like subdomains top 1,000,000.txt, right? And in this case, we don't have a domain that we can work with, but what this would look like is as follows. So head over into my terminal, ffuf, we specify the URL here. We say fuzz.hackersploit, well, that's incorrectly typed in, hackersploit.org. And then we can output that in colorized format. And then the word list is user, share, sec lists. And then, we can say, is that under discovery, web content? Well, actually under DNS, not web content. So DNS, and then we can use any of these word lists here. So for example, the fierce host list is quite useful in my opinion. So there we are. We'll let that run, although in my case, I don't think this might work, although we can always try it out. Let's see whether we're able to enumerate any subdomains for my particular domain. All right, so yeah, this looks like it's going to take a while, so I'm not going to go through with that, but as it says, this is not one of its strong suits. As it says here, you can also, as it says, some subdomains might not be resolvable by the DNS server you're using and only resolvable from within the target's local network by their private DNS server. So that's fairly normal. We expect that. Some virtual hosts, VOs, may exist with private subdomains, so the previous command doesn't find them. To try finding subdomains, private subdomains, we'll have to use the host HTTP header, as the requests might be accepted by the web server. So the instructions for that are provided here. As you can see, you need to provide the host or the header, and then of course fuzz the actual subdomain there. And yeah, so that's how to do that. I'm not going to be covering that because, as I said, that's not really one of its strong suits. Let's take a look at proxying with proxying ffuf traffic, which is quite useful. So if we want to proxy the requests through Burp Suite, for example, you can actually utilize or do that using the X option, and then pass in the proxy parameters or URL. In the case of Burp Suite and with OWASP Zap, that is going to be a local host under port 8080, right? So again, for example, if we wanted to do this here, we would say get rid of that there. Let's go to a shorter parameter list here. Is that the correct IP? I believe 125. No, that's not the correct one. Let's use this one here, right? So let's say we just wanted to fuzz the root of the web server. So fuzz, we can output that in colorized format. Let me just get rid of the single quote there. There we go. And then we can say, user share, sec lists, and then discovery, web content, and then common.txt, and then we can say x, http 127.0.0.1. Make sure you have Burp Suite started up, and we'll hit intercept on. I'm going to hit enter now. There we are. We can see Burp Suite opens up, and we get the first GET request here for the file.web, and then we can forward it or drop it or send it to the repeater, but that will really be quite stupid. We can confirm that the user agent is fuzz faster you fool version 1.3.1, which is a Kali exclusive for those of you who didn't know that already. So we can hit forward, .perf, .getConfig, MySQL history, so on and so forth, and then you can view the response, etc., etc. So that's how to proxy ffuf traffic, through burp or any other proxy tool that you're using. So yeah, that's fairly simple. As it says, it's also possible to send only matches to your proxy for replaying, and that can again be done by saying replay proxy, which is fairly simple, and then you can do that with burp or any other proxy. That's done. That's fairly simple to understand. And then reviewing the options, right? So it says here, as you start to use ffuf more, some options will prove to be very useful depending on your situation. For example, IC allows you to ignore comments in the word list, such as headers, copyright notes, comments, etc. So for example, under directory list 2.3 medium, you have quite a bit of commentary or actual documentation here, which you might want to actually try and exclude. So, we can actually just copy this command and see what they're talking about without the IC option, which actually ignores comments. And then, of course, we can actually do that here. So let me just terminate that there. If we do that right now and hit enter, that's going to ignore the comments. If we do that without providing the IC option, you can see that the comments are provided here, and for some reason it provides status codes for the comments, and you can see how messy that output looks. So the IC option is quite useful there. All right, so it's going to say, how do you save the output to a Markdown file? So ffuf allows you to output your results into various file formats. So if I say ffuf help, we can take a look at the output format here, and then we say output format MD, and then we specify the file name. So if we were to do that, we would say output format MD, and then ffuf.md. Hit submit. There we are, that works. The way that would look like is as follows. So for example, if we were doing the same thing here, we could ignore the comments. Ignore comments, and then we would say output format, and then that's MD, and then we could say ffuf.md, hit enter. That's going to output it into the Markdown file. As I said, you can do that in various other formats. For example, if I can actually find that here, output formats, there we are, JSON, which can be great for importing it or utilizing it with a web application. HTML, MD, CSV, ECSV, or you can output or use the all option for all formats. And you can also specify the output directory if you want, right? So if you want to reuse a raw HTTP request file, we're not actually covered that. I'll probably be making a video that highlights that in the future. That's under here, so there we are, that's request, so we can specify that there. There we go. Submit. How do you strip comments from a word list? That is IC, as we already know. How would you read a word list from standard input? So that's -w-. There we are, that's correct. How do you print full URLs and redirect locations? I believe that's R. And no, that's incorrect. How do you print full URLs and redirect locations? Let's actually take a look at that right now. Redirect output, that is V. So for verbose output, because we're outputting the URLs and redirect locations, so that's verbose output. That's not really recommended with this tool. What option would you use to follow redirects? That's the R option, as I'm quite familiar with that. And how do you enable colorized output? That's C here, and we hit submit. And that looks like that is done. This is more information about the author of this room. And yeah, we're pretty much done with that room. So we can hit complete, that's done. And there we are. So that is how to use ffuf. That's just a general introduction. There's many other ways that you can use it. As I said, it's a great place to begin is the documentation page. As I said, you can also change the rate. If you want to increase the rate, also the timeout. So HTTP request timeout in seconds. So for example, I can say in this particular case, let me just get rid of the output options here. We'll say that the rate is maybe something like, let's say we wanted 10 there, and then the timeout options, which I want to actually highlight here. There we are, timeout. If we say timeout, We can change that to maybe 20 seconds there. We hit enter. As you can see, the timeout has been changed and the rate has also been changed there. And yeah, that's how to modify that. If you want to change the threads, let me actually take you through that as well, because that's quite important when utilizing a tool like this. Let's take a look at the option here. There we are, that's the thread. So you can also change the amount of threads. So if I wanted to say maybe something like 100 threads, which I really don't recommend, but you can see it changes the threads to 100 there, and that will speed it up, but it may also cause a denial of service type of situation if the web application is being overloaded, you know, so on and so forth, right? So that's going to be it for this video. Let me know what you guys think of this tool. As I said, it's a fairly recent tool, one that I've been learning how to use, incorporating into my own pen tests and engagements. I'd love to know what you guys think. The write-up for this video will be on our blog at HackerSploit.org. If you want to join in the discussion, you can do that on our forum. So that's forum.hackersploit.org. or on our Discord server. The link will be in the description section. And yeah, thank you very much for watching, and I'll be seeing you in the next video. A huge thank you to all of our Patreons. Your support is greatly appreciated, and this is a formal thank you. So thank you Shamir Douglas, Ryan Carr, Sandor, Michael Busby, Sid Saab, Doozy, Tafim Bari, Dustin Umpress, and Michael Hubbard. Your support is greatly appreciated, and you keep us making even more high quality content for you guys. So thank you.